My name is Gagement, and I'm here to give a tutorial on slope-intercept form. Slope-intercept form is y equals mx plus b. B is the y-intercept, and so that is whenever x is 0 and whatever y is for that equation, while m is the slope, so it's how it goes up or down in what direction. 3x plus 2. Here, I have the graph and the table that I'll be using to show you how we would graph this. So, since we know the y-intercept is 2 from the equation, that would mean at 0, for the x, we'd know it would be 2. And so if I graph that there, then we have 1x to be put in, and so then we'd know we had to go 3 up, because 3 times 1 would be 3, and so we would go 5 is the new y, and so 1, 5 is right there. Then we, over here again, it's the same thing. We just go up 3 and the y. I mark it down over here for 2, 8. That's how you get the first one graph, plus 3. Here, we immediately know that the y-intercept is 3 due to b, the b term, in this case number 3. And we also know the slope is negative 2, meaning we'll go down 2 for every x. So, we're going to have 3 minus 2 is 1. You can tell by doing this. And then, if you subtract 2 again from 1, you get negative 1. Because there is a negative sign in front of the 2x, that'll mean the line is going to go the opposite direction. And so negative 1 times negative 2 is positive 2. But I forgot to include the y-intercept, and so then it'd be 5. So if you graph all these, you'd go up here for negative 5, or negative 1, 5, and then 1, 1 be down here, and negative, or 2, negative 1 would be down here. An observation we can make from this is if we check, there seems to be a reoccurring theme between each of these points and how far away they are from each other, and that would be to expected, but that's more important later on. And so in this situation, we realize there's minus or plus 1 minus 2, and this is like you would think this would be the x for going up 1 at a time. This is the negative 2. Now this is a slope triangle. It's very useful for figuring out these sorts of things. Now we got something new. There isn't always a number in the place for m. Sometimes, like in this example, there can be a fraction. It's important to know that whenever m is a fraction, there's a secret trick they can do, or not so secret. Here I have y equals 1/2 x plus 2. Whenever you do slope-intercept form, you don't always have a positive or a full positive number in the m place. And there's a trick that can help you solve this. Instead of having to do the crazy math and put it into a table. And so that is that the numerator, you need to know, is rise of, or well, it's important to know the rule rise over run. And this would mean that the top is y, the numerator, so 1, so for every, so whatever it says here, it goes up that many in y, while the bottom, the denominator, is the run portion, and so that's how far x it goes for every, that's how far it goes on the x-axis for every time. So we have our table and graph again. We immediately know again that the y-intercept is 2. Now we use my trick that I told you about to know you go up 1 to here, so right there, to 3 from 2, and then you go over 2 more. And so I'd be right over here on 2, 3. And I write that down. Now we know it's gonna go up 2 over here and 1 over here. So you can immediately, or you can imply that it's probably gonna be 4 and then 4 here. And so you can use the slope triangle, or you can use your trick, this trick again, and count up 1 plus 1 over 2 over 2, and that's your line. Now things aren't always this simple. There is sometimes when the fraction can be negative. This may make it seem that'd be a whole lot harder, but it isn't. All you have to do is that, I'll rewrite it, you just have to know that the top takes a negative, not the bottom as well. And so this would mean, if we go back to rise over run, that you would go down in y for every time, for every x, but you still go across on the x-axis as normal. That's important to know. Lastly, we have this problem. I'd like you to try graphing yourself. I've given kind of the stuff you need to figure it out, and so I'll give you a minute to pause the video and try it, and I'll show you the answer. That should be enough time. So we can imply that we can see that here we have a change of 3 in x, while for y we have a change in 2. And so that means it should be the same again. Change in 3, change in 2. Now we can check that over on the graph. How does that, is it the same? So 0, 3 is here. Now we go over 3, and so it'd be over here, so we can write plus 3, and then you go up 2, plus 2. That's the next point. This would be 3, 5. 3, 5. Now, we know this. Now I gotta write the actual equation that we believe it is. So, we can write y equals, and so we know we go over 3 and up 2. And so, according to rise over run, we put where the change in y is on top, and change in x on the bottom. So in this case, 2/3 x, and then we know the y-intercept is 3. So plus 3. And I check my answer, and there it is. Now, these are kind of the basics on how to solve slope-intercept form. I hope this helped.